Let's do an order switch for a double integral. Now, what you're going to find a lot in Calculus 3 is switching the order of integration is just a good academic exercise, and often one that's necessary when you're doing problems in mathematics as well as engineering and science. So we start out with the integral I. We have the x variable running from -3 to 3 and the y variable running from 0 to the principal square root of 9 minus x squared. And we want to switch this. Now, first thing we do is we just notice, again, the y variable corresponds to the first set of innermost limits, and the x variable corresponds to the outermost limits. So remember, that's how we read our integrals. Now, when we do that, we see that y runs from 0 to the square root of 9 minus x squared, and of course, x runs from -3 to 3 right here. Now, when we look at this, we see that the y variable is non-negative, and the x runs from -3 to 3. So as we make those substitutions here, we see the largest that y can be is the square root of 9, which is 3. So automatically we get this result if we're thinking of y as being independent. And then we need to work on the first inequality. So what we can do, notice, is we can apply the square function. Again, for this interval, the square function is increasing, so it will preserve this inequality. So when we square it out, we get 0, y squared, and 9 minus x squared. And then, if you will, solve for x squared just by transposing the additive inverse of x squared to the left here, and we get x squared is less than or equal to 9 minus y squared. Okay, so now of course we just need x. So what we'll do now is apply, again, this is non-negative, we can apply the square root function, which again is an increasing function, which will preserve this. So when we apply it, we get the square root of x squared, as you've noticed here, which is the absolute value of x, and then we get less than or equal to the square root of 9 minus y squared. So that's really nice. Now, of course, that just is a conjunction, which we can write as a compound inequality. That is, this is the positive number, the c, so to speak. So we have x between the positive square root of 9 minus y squared and the negative square root of 9 minus y squared. So now we have a new representation of r, where we look at y here as being independent, and then of course the x being dependent on the y. Now, if you don't like to do all of the algebraic maneuvering, you can always look at this in a sketch. That is, the original or r, original, or this one, it doesn't matter, is just representing this arc here, this half disk of the circle. And so a lot of students like to look at it that way. So for instance, when you think of it that way, for the first representation, we're running this way. The x is independent, and we figure out the y's. Now, of course, when we flip it around, the y is independent, and we move in a horizontal direction. So that would be another way of thinking about this problem in a graphical sense, but it's certainly very important to be able to do this algebraically. And so now the original integral can be written using this representation of our region of integration. And so now the independent variable, or the outer integral, is the y integral from 0 to 3, and the dependent integral is the inner integral, the x in this case, from negative square root 9 minus y squared to positive square root 9 minus y squared. And we are done.